teach you how to do integration by partial fractions. Why do we do this? The reason is there are some functions that do not have just a simple antiderivative. For these problems, the case is mainly going to be a constant in the numerator and a polynomial in the denominator. Most of the time it's going to be a quadratic that can be factored. For this reason, we can transform these functions into an easier form so we can take the antiderivative. So, how we do it? We use a method called partial fraction decomposition, and the first step is to just factor the denominator. As you can see here, we took the denominator, the x squared plus 3x plus 2, and we factored that into x plus 1 and x plus 2 and left the numerator. So then the next step is to split the factored form into two separate fractions. For this case, we're going to have two fractions, and one of them is going to have one of the factored terms, and the other is going to have the second. For now, we just label the numerators a and b because we don't know these constants yet, but we're going to find them in the next step. Let's say we want to start with finding a. The first step is going to be to multiply every term in this equation by the denominator with the a, which is x plus 1. That will cancel. That's going to leave just a, and then it's also going to leave just 6 over x plus 2 on the left, and then b times x plus 1 over x plus 2 on the far right. So now we're going to isolate a, and what we can do is just plug in a minus 1 for x. That's going to cancel out the term with the b in it, and then give us a constant on the left side. So as you can see, we get a equals 6. And for b, we would just do the same thing by multiplying x plus 2 to every term, and then we're going to plug in a minus 2 for the x, and that's going to cancel the term with a and make that 0, and leave us with just b. There's good news. There's a shortcut to this, and it's called the cover-up method, and that makes this process of partial fraction decomposition a lot quicker. This is how it works. We're going to get to this form that we were in, set up this equation, 6 over x plus 1 times x plus 2 equals a over x plus 1 plus b over x plus 2. Then you've got to take your finger and just cover up the x plus 1 factor on the left, and you need to think about what makes this go to 0. And when you realize it's minus 1, and remember this is using the previous example, you plug that in for x on the left, and you'll get 6 for a. So I'm going to show you how to do this process. So back to the previous slide, this is how you would do the cover-up method. Just watch what I do with my finger. So let's say I want to find a. I'm going to cover up this x plus 1, and then I'm going to plug in a minus 1 in for this x. So then minus 1 plus 2 is going to give you just a 1 here. 6 over 1 is 6, so a is 6. So if I want to do this for b, I cover up this x plus 2. I think what makes this denominator 0, that's a minus 2. So I'll plug in a minus 2 here, and that'll give me a minus 1. 6 over minus 1 is a minus 6. Where does the integration come in? It's going to come right after we do the partial fraction decomposition, and that's really the hard part. Once we get through that, it's easy from there. So back to the previous example, we had this integral, and now since we found a and b, we've turned it into this. And now we just need to integrate each term, which is going to give us 6 natural log absolute value x plus 1 minus 6 natural log absolute value x plus 2 plus c, because remember this is an indefinite integral. And always remember the absolute values. All right, we're going to do one more example, and this is a definite integral. So first step, remember, we're going to do the partial fraction decomposition. Just ignore the integral and the bounds for now. Those will come back. So we factor the denominator first. We get 3 over x minus 1 times x minus 2. Now we're going to split that denominator up. So we have on the right side a over x minus 1 plus b over x minus 2. I'm going to demonstrate the shortcut one more time. So let's say we want the a term. We're going to cover up this minus 1. 1 is going to make this 0. So 1 minus 2 is a minus 1. 3 over minus 1 is a minus 3 for a. If we want b, we're going to cover up this minus 2, plug in a 2. 2 minus 1 is 1. 3 over 1 is 3. So now we're going back to the integral with our new function in this form. And when we integrate that, we're going to get 3 natural log of x minus absolute value x minus 2 minus 3 natural log absolute value x minus 1 evaluated at 3 and 2. So now when we plug in the bounds, we can see that we had a natural log of 0 in there, which we know does not exist. So this integral in this case doesn't exist. And just a final note, if there are more than 2 terms in a partial fraction decomposition, you can still use the shortcut. You're just going to do it with more terms and it'll work just the same way. And remember, this can only be applied when we have linear, non-repeating terms. All right, thanks for watching, guys. That's how you do integration by partial fractions.